So um, the heat getting rejected. So it will be T2 times S3 minus S2. So that is the, sorry, T2 times S3 minus S2. So that we already know. But the term heat getting rejected from a system, thermodynamically, it means some loss is happening to the system because system is losing its energy when heat is getting rejected. For example, the system means the working fluid in our refrigerator. നമ്മുടെ refrigerator working fluid അല്ലെങ്കിൽ refrigerant. Refrigerant is the thermodynamic system which is carrying out all the work, which is doing all the work in our refrigerator cycle. So when the working fluid is rejecting the heat, the working fluid or the system is losing its energy. So this term is a negative term, or we have to add a minus here. So it will be, we can assume, or we can denote this heat getting rejected as minus T2 into S3 minus S2. So in order to remove that minus term, we can add a minus here at S3, and we can add a minus at S2, so it will become plus. So that is why T2 into S2 minus S3, that is what is shown over here. So that is what is shown over here. So the heat getting rejected is T2 into S2 minus S3. Okay, so T2 into S2 minus S3 minus T1 into S1 minus S4. So here we know S2 and S1 are same, S3 and S4 are same. Again, once again, S2 and S1 are same, S3 and S4 are same, because 1 to 2 is a isentropic compression process, 3 to 4 is a isentropic expansion process. So we can cancel out all these entropy terms. So whatever is remaining here, T1 by T2 minus T1, where T1 is the lower temperature in our refrigeration system, T2 is the higher temperature in our refrigeration system. അല്ലെങ്കിൽ ഇങ്ങനെയും പറയാം, T1 is the temperature of the low temperature region, or the low temperature source. For example, the freezer compartment of a refrigerator. T1 can be assumed as the temperature maintained in the low temperature source, that is our, for example, our freezer compartment, and T2 is the temperature maintained in the high temperature sink, which can be assumed as the surrounding atmospheric air which is surrounding our refrigerator. So T1 by T2 minus T1 is our coefficient of performance, or COP, of a Carnot refrigeration cycle. അപ്പോൾ ഈ ഒരു റെഫ്രിജറേറ്ററിന്റെ പെർഫോമൻസ് ഡിറ്റർമിൻ ചെയ്യുന്നത് അകപ്പാടെ അതിന് 2 ടെമ്പറേച്ചേഴ്സ് മാത്രമാണ്. Okay, our whatever may be the size or rating, or the brand, that is the manufacturer, whatever be the manufacturer of the refrigerator, the performance of a refrigerator is determined mainly, or it is dependent only on the operating temperatures. That is, what is the lowest temperature maintained in the refrigerator, what is the highest temperature what is the highest temperature or the higher temperature maintained at the surroundings. These two temperatures are determining the performance, or the effectiveness, or in a way efficiency also, of our refrigerator. Okay, so here we can do a so here we can do a small problem over here. So I request all of you to take a piece of paper or a notebook So we can do a small problem. So I request all of you to take a piece of paper or a small notebook or anything, or a scribbling pad or anything. So we can do a problem. So it's a very simple problem like that. In a reversed Carnot cycle, or in a reverse Carnot, so reverse Carnot cycle means ഈ ആ പേര് കേട്ട് പേടിക്കേണ്ട കാര്യമില്ല. The reverse Carnot cycle means we here our Carnot refrigeration cycle is the reversed cycle of our heat engine. Carnot heat engine just reversed effect ആണ് നമ്മുടെ refrigeration cycle. അതുകൊണ്ടാണ് ഇതിനെ reversed Carnot cycle അല്ലെങ്കിൽ reversed Carnot refrigeration cycle എന്ന് പറയുന്നത്. So in a reverse Carnot cycle, the following temperatures and entropies prevail. T1, our lower temperature, for example, our freezer compartment, it is maintained at 250 Kelvin. T2, our surroundings temperature, 300 Kelvin. Then S2, or the entropy available at the surroundings, for example, 1.2 kilojoules per kilogram. S3, S3, S3 equals 0.9 kilojoules per kilogram Kelvin. Find the magnitude of the refrigeration and the heat rejected. Also find the net work done on this cycle. We have to first of all find the magnitude of refrigeration and the heat rejected. Also we have to find out the net work done in the cycle. So നമ്മുടെ ഈ സബ്ജക്റ്റിൽ നമ്മൾ ഏതൊരു പ്രോബ്ലം കിട്ടിയാലും ഇതിന്റെ ആദ്യം ഇതിന്റെ സൈക്ലിക് റെപ്രസെന്റേഷൻ അല്ലെങ്കിൽ ഇതിന്റെ ഒരു റിലേറ്റ് ചെയ്തൊരു ഗ്രാഫ് വരയ്ക്കാൻ നിങ്ങൾ ആദ്യം ശ്രദ്ധിക്കുക. ഓക്കെ, സോ that is what we are that is normal procedure we are to be followed in any of our thermodynamics related subjects. So here it is very easy to represent a temperature versus entropy diagram or TS diagram. Then we have already learned the representation of our Carnot refrigeration cycle, that is 4, 1, 2, 3, and 4. 4 to 1 is our refrigeration step that we have already discussed in the last just now. 4 to 1 is our refrigeration step, or the absorption of heat from the low temperature source, for example, our freezer compartment. Then 1 to 2 is the isentropic compression process. 1 to 2, the compressor working. Then 2 to 3, നമ്മുടെ സറൗണ്ടിങ്സിലേക്ക് ഹീറ്റ് റിജക്ട് ചെയ്യുന്ന പ്രോസസ്. 2 to 3 is our again isentropic heat rejection, isothermal heat rejection process. 2 to 3, it is the isothermal or constant temperature heat rejection process. Then 3 to 4 is our again constant entropy expansion process or pressure reducing step. So 4 to 1 is a isothermal heat absorption, 1 to 2 is a isentropic. So sorry for the disturbance. So so 2 to 3 is the 2 to 3 is the constant temperature heat rejection process. So we have to first of all find the magnitude of refrigeration, which means magnitude of refrigeration is happening from 4 to 1. So in TS diagram, the magnitude of refrigeration is nothing but QA, or heat absorbed. Q is the general term denoting the heat term, and A stands for absorbed. Heat absorbed is given by T1 times, or the lower temperature T1 times S1 minus S4. S1 minus S4. T1 times S1 minus S4. So you can you can calculate the answer for yourself. T1, both T1, S2 and S3 are given. So here you can see S2 and S3 are given, not S1 and S4. But you can see in the TS diagram, S2 and S1 are same, S3 and S4 are same. So there is no confusion. So T1 into S1 minus S4, you can calculate for yourself the answer. Then heat rejected. The next thing we have to find out is the heat getting rejected. So the heat getting rejected, QR. That is happening, heat getting rejected, 2 to 3. 2 to 3, the heat getting rejected is happening in 2 to 3 process. So the expression for that heat getting rejected is T2 times the both T2 and T3 are same. So we are taking that constant temperature as T2. T2 times S2 minus S3. ഇതെന്തുകൊണ്ടാണ് S2 minus S3 വന്നത് നമ്മൾ ഓൾറെഡി ഡിസ്കസ് ചെയ്ത് കഴിഞ്ഞു. We have already discussed why this S2 minus S3 is coming here. So S2 and S3 are given the question itself, so you can easily find out the answer for yourself. Then net work done. So the then we have the third, the next we have to find out the net work done in the cycle. So the net work done, we have to uh, so here we are discussing a Carnot refrigeration cycle. All the processes are ideal or reversible. So in a reversible or ideal cycle, the net work done will be represented as heat rejected minus heat absorbed. Already നമ്മൾ ജൂനിയർ ക്ലാസ്സിൽ പഠിച്ചു കഴിഞ്ഞിട്ടുള്ളതാണ്. So heat rejected and heat absorbed are shown over already found out. We can simply subtract one from the another. We can easily calculate the answer. Okay. So all of you, please calculate these three answers. Okay.